welcome to this notebook on data planning and data collection of our DataLitMT project. So maybe you have already watched our notebook at the basic level, which discusses the same process of collecting your data and preparing it for NMT training purposes. But this notebook is the advanced level, so we have split up the steps, and I will explain that in a little more detail here. So welcome to a walkthrough of this notebook. So the same as on the basic level, we have prepared some introductory information for you that is available in the notebooks. So first of all, the notebooks are structured in the sense that we have sort of an even split of theoretical information and text written information, as well as codes in this notebook. So as you can see here, this would be the theory part with some text that explains sort of background information that is very relevant to know. And then below you will always find code cells that you can run, and I will show you exactly how we will do that in a moment. So this notebook talks about how you can find data and how you can download and prepare this data to then train your own NMT model, which we also show you in our NMT training notebook, if you would like to do that later on. So the most important thing is, where do we get this data from? So a very relevant place to find data for machine translation is the Opus page. So we can click here. We have linked all relevant articles or web pages. The Opus webpage is a website where you can download bilingual parallel data for machine translation purposes. It is very resourceful. And the way you can do that is that you select your languages here. So in our example, we're working with English and German. So we can select English here, for example. We'll select that as one language. And then the page just reloads for a second. And then here we can select German. Obviously, if you wish to work with a different language pair, you just select your language that you would like to work with, for example, French or Chinese or whatever you would like to work with. And then here it shows you all the data sets that they have available for English and German, and you can see that there are a lot. The higher up we go, the bigger these data sets are. So as you can see here, the Paracrawl data set, for example, almost has 300 million sentences. And the lower we go, we get 500,000, a few thousand, and so on. The dataset that we're working with for our example is the TED 2020 dataset, so from TED Talks. And you can find this here. And we can see, okay, that has 0.3 million sentences, so around 300,000 sentences. And we can see here, okay, it's German, English. And it is always very helpful to look at sample of the data set, and then it shows you kind of how the data set looks like, what kind of sentences they have, what the structures, what the form of the sentences is, the tone, and it shows you, for example, the German sentence and the English sentence. And this is would be, for example, the two aligned sentences, and it just shows you a little sample of the data set. So it's always quite good to have a look at that. But we can go back. And the way we download this data set is we go back to 2020, and what we use is the Moses format. So you can either just click on it here and download it straight away, or you can right click and copy the link. And the link is the one that you see down here in the left-hand corner. And once you have copied the link, we can use it in our notebook. So this URL that you see here, that is the link that we've just copied. But obviously we've done all of this for you. So for this notebook, you don't have to change anything in the cells. You can just click through them without having to change anything. But if you would like to use a different data set, then you could change it. Then you would need to, for example, here use your URL. But then also in the following cells, you would always need to refer to the data set that you have downloaded. So here I will show you how to run through it and what what we will see as outputs. So we can just click on that cell, and then the dataset will automatically be downloaded into this notebook. So some of these cells take a few moments longer to load than others, but usually it's all quite doable and it doesn't take too long to, for example, download this data. So as you can see here, now we have the TED 2020 DE, so that's the German data set, and the TED 2020 EN, that's the English data set. So these are the two data sets that we'll be working with, and we don't need the XML file for this notebook. So once we actually have this data now in this notebook, you can also see on the left-hand side here in your local notebook folder, you can see that these files are now downloaded here. So as long as we use this notebook, as long as we don't close this window or the computer shuts down, we have this data here in this notebook. And at the end of the notebook, I will show you how to actually save this data either locally or to your Google Drive, so that we don't lose our data and we can actually use it in the following NMT training step. So now that we have the data here, we have the TED 2020 German and English data set, we can just install some necessary requirements that we need to work with. So those are a few that we are kind of calling on later on in this notebook. This always loads for a moment. And this information here is quite interesting to see what is going on, and that you've successfully installed, for example, a sentence piece, which we'll use later on. But this is not information that we need to specifically look at. So by clicking on the little cross here, you can just cancel it because we don't need to visually see that information. But you can see here on the left-hand side, there's a green tick. So that shows that this data has actually, this cell has actually been run. And that's always the confirmation tick. Now we need to actually define our data sets as variables. So this would be a variable so that we can call on them later on. So for this example, we use English as a source and German as a target. So we can define our source file, the English TED dataset, and as the target file, we'll define the German TED dataset. And then we also need to define our languages. So the source file will define as English and the target file as German. These are the specific language codes. So if you work with a different language pair, you would need to define your language code, for example, FR for French. So we can just run this cell as well. Like before, we don't have to change anything. And now we actually move to filtering and cleaning these data sets, because for NMT training, it's very important that data sets are kind of prepared well. So the most important thing is that naturally they are parallel and that they are aligned, so that one sentence in the English is the exact, in the German data set, it's exactly on the same kind of parallelly aligned segment. But there's more kind of noise in data sets that we don't need for NMT training. So for example, if there are empty cells or if there are duplicates in the cells, we don't need these for NMT training because it's not helpful for the models to train on. So we delete a few things here to kind of clean our data set. So this is what we do in this section. And this is kind of very split up here. So this is just to show you what is going on. If you're not as interested in the specific steps and you just want to do it in one click, you can look at our basic level notebook because it's a bit more compact in that notebook. But the process is the same. So here we can see, first of all, in order to work with our data set, we need to create data frames. So data frames is a form of a tabular data structure that contains labeled axes that we can then work with. This pop-up might show up once in a while as a when you're working with notebooks, then you just have to click that you're not a robot. And you can see here that we first define a data frame for the source. So it reads the source file as we have defined it up here, our English source file. And down here, we define a target data frame where it reads the target file, the contents of these files. And then we create one combined data frame. DF stands for data frame, and it combines the source and the target so that we have them aligned and we can work with them. So first of all, it shows us how many columns we have. We have 2 columns because we're working with 2 languages, and how many rows we have. So remember we said that this data set has almost around 300,000 segments. Well, here it says 296,000 segments. So this is what we start with. But now we'll lose some of these segments because we'll delete some that we don't need. So the first thing, for example, we do is we delete empty rows because we don't need to work with, empty rows doesn't help NMT training. So this is what is happening here. It's just dropping. NA is just, for example, in this case, missing data. So we're deleting that here. In this step, we are deleting duplicates, which means that if there are 2 segments that are the same throughout the data set, that we delete those because we only need one version of the same segment, of the same sentence. And for source copied rows, we're saying if there's something that's the same in English and in German, maybe a URL or something, we do not need that for NMT training either, and that can be deleted. You can see always it prints us in the end how many segments we actually have left. So we can already see we've already deleted quite a few from the start. In this section, we can delete sentences that are too long, and with too long is something that you can define yourself. So we define here what we consider too long, because at one point, if sentences are too long, that can also be unhelpful for NMT training. So in this case, we want to set a limit for how long the sentences should be, but this can be defined individually. But of course, here we don't need to change anything ourselves. We can just run the cells. In this cell, we delete HTML code because that is also irrelevant for NMT training. We don't need to do that. This cell we run to list how many rows will remain in true case form. And true casing is something, a common NLP problem where sometimes the proper capitalization of names or at the start of a sentence kind of goes missing. So in this case, we want to see how many rows we have actually remained that are well formatted. And in this cell, we again delete empty cells that have kind of a NaN, which is also considering missing data. So the NaN stands for default missing value. It's a marker, and it's used for reasons to speed up the computational speed and just for reasons of convenience. So here we delete again missing data. And then lastly, we shuffle rows because we're working on a sentence level. So the rows will be shuffled in the original data set. So each time you would start this notebook over again, the rows will also be shuffled in a different manner because this is done randomly. Because the NMT training systems don't look at the rows one by one as it would maybe on a document level training. So the rows are always shuffled if we're working on a sentence level. And you can see these are the rows at the end that we have left. So it's a little less than we started with, but we still have almost 300,000 sentences left. So now we can actually prepare this data. So we will define our new variables as filtered. And we can now save this data. And we now have our filtered source file. And you can see it has filtered added to it. And our filtered target file, and you can see it also has filtered added to it, and the English and German at the end. All right, something that is also a very good practice to do is to check whether this has been done properly. So now here we can print the first and the last 2 lines of each data set. And if you speak the language, you can see whether this has been done correctly. So we can see, okay, this is the first line of the English data set, and this is the first line of the German data set, and the same here, it's the last and it's the last, and you can see, okay, it's a translation of it, so that makes sense. So everything has been done correctly so far. So next on, we move to tokenizing our data set. So as you can see above here, the data is still a natural language. So that is obviously how we humans read the data, but computers don't read the data as natural language. They need to be processed. So they are subworded, which means that they are split into subwords, so units, smaller units. And we can see this by the example here. For example, when we have 4 words, low, lowest, high, and highest, these can be represented by 3 subwords, low, high, and est. And that would reduce the required vocabulary size of the NMT model by 1. So we are reducing, so we're kind of splitting up larger words so that the models can train better on them, and then they can combine these subwords in the end to form longer words. And one toolkit that is used for subword tokenization is called sentence piece, and this is the one that we're using here as well. So what we will now do is we will train our own sentence piece models, and then we can apply those to our data and actually subword it ourselves. So in order to do that, we need to import some requirements so that we can use sentence piece here. And we can create a path that we can refer to. And now we can actually train our sentence piece models. So we will train 2 different subwording models, one for the source data, so one for the English data, and one for the target data, so for the German data. Because naturally the language is different, so the words might be split differently, subworded differently. So you can simply run the cell, and then the sentence piece model will train for the source data, and this might take a while. And then it is done, and you can see done training a sentence piece model for the source. And then we can do the same for the target. So now we train it on the target data, and you can always see here that we refer to the source file. Here we refer to the source file. Here we refer to the target file. So it's always important to check that, I mean, in this case, you don't need to change the code for anything, but it's always good just to make sure that you don't confuse, for example, the source and the target, and that everything is trained correctly and separately. Perfect. And then you can also see here, done training a sentence piece model for the target file. So now we have the 2 models, and now we can actually subword our previously filtered and cleaned source and target data set. And the models that we are working with is now the source model for the sentence piece, for the source file, and the sentence piece target model for the target file. And these are the filtered data sets that we're working with. So we're just referring to them. You need to load also the sentence piece processor. And now we can actually subword the source data. So here you can see we're working with the source model, and we're working on the filtered source file. So this will load a moment now, because the data set will now be subworded. And then it says in the end, done subwording the source file. And the output we receive is this one. And you can see it's the filtered English file, but now it has the subword at the end. So we know that this is now the subworded source file. So the file names are getting quite long here, but it's quite important because it's very clear what we're working with. We know that we're working with the filtered English subworded file now. So these file names can obviously be changed later on if you would like to, but we recommend leaving them because we're always referring to the names the way that we're defining them here. So it's quite relevant to, for now, keep them the way that we define them in the process. So this is the source subworded file. Now we also need to subword the target file. So here we're calling the target model and the target filtered file. Perfect. Now you can see done subwording the target file, and we have the German filtered subworded file. And once again, we can check our data set. So now we're checking our subworded files, and you can see that we have correctly subworded them because you can see the underscore in front of the words. And that is one form of subwording. And in this case, it has we've successfully subworded the data, and this is the data that we then can feed the NMT system to train our models. You can also see on the left-hand side that the filtered subworded files have been saved here on the side. All right, now that we have actually subworded our data, we need to split the data sets, because to train NMT models, similarly as to train other machine learning models, we need different data sets. So we need a training data set, the data set that the machine actually trains on. Then we need a development data set, or often referred to as validation data set, because this validates the training of the NMT model. So it checks how well it is training. And then we need a test data set to, in the end, actually test the performance of our NMT model. So the test data set is the one that we save up until the end. And then we use this one to create a translation. And the most important thing is that the training data set is the largest by far of all three, because it needs a lot of information to train on. So the training data set is usually around 70 to 80% of the original data set. And then the development and the test data sets always need to be of exact same size. And that is usually between 10 and 15% of the original data set. So what we do now is we split the subworded English TED file and the subworded German TED file into 3 sub-data sets. And we define, first of all, the size of the development and the test data sets. So remember, we're working with almost 300,000 segments. So we can say round about 35,000 is around 10-11% of that. So we define, okay, the size of a development and the size of a test data sets are going to be 35,000. And then here, once again, we can create a data frame where we now work with the subworded files that we've created above. And once again, we can check if there's any empty cells. In case, we can delete them. But you can see there were none because none have been deleted, so that's good. And now we can run the cell below to extract the development and a test data set from the main data set. And now here we can run the cell to write the data frame to the source and the target files. And we will see that we will in the end have files ending in train for the training data set, in dev for development data set, and test for the test data set. So now we'll create the data frame for the training data. We'll create a data frame for the development data. Now we'll create a data frame for the test data. And now we can run this cell where we have all our files. So now we actually have the files. So we have the filtered subworded train dataset for English, for German, and then also the development for English and German and the test dataset for English and German. Since we're working from English into German, the English test dataset will be used to translate into German using our NMT model later on, and the German test dataset can be used as a reference. And as you can see above here, we've defined the development and the test datasets to be of 35,000. So if we subtract these two from the original dataset, the rest will be written to the train file. So we can check down here how long our datasets actually are. So we're doing a count, a line count or a sentence count, and we can see down here that the development and the test datasets both have 35,000 lines, segments, as we've defined, and what was left over has been written to the training dataset. So 216,843 was left over, so that has been written to the training dataset, and that is around 70 to 80% of the original dataset. So it is important to see that these are of exact same length, because for NMT training, it needs to be exactly parallel. So if there would be a misalignment or one dataset would be one line longer than the other, it wouldn't work. They need to be of exact same length, so it's always good practice to check the length of the data sets. Perfect. So now we have our filtered and cleaned and subworded data sets split into 3 sub-data sets that we can now use for NMT training. But as I'd mentioned before, these data sets are still merely saved locally here in this notebook. So now we have 2 options of actually saving these data sets to your computer. So one option is that you can save them locally, so in any file on your computer. And as we looked at before, on the left-hand side here, now you can see there's been more data sets created, more files. So if you hover over them, you can see, for example, this one is the development dataset for German. If you click on the right buttons, on the right dots here, you can download this dataset, this file. So you can do that for the development, the test, and the train data for German and for English. You're also welcome to download the full, like the complete subworded data or the unsubworded data, but filtered data, you can download all of them, but the most important ones that you will need are the train, development, and test data sets. So the 3 sub-data sets. We will definitely need those later on. And also very important to download is the source model. So this is the sentence piece source model that we trained earlier, and the target model, the sentence piece target model, because now we have subworded our data, but later on in the NMT training notebook, we need to de-subword the data, the translation, because when we produce the translation with our NMT model, the output we get will also be subworded. So it will contain the underscores, but in the end, to have a clean translation, we want to get rid of those underscores. So we want to de-subword the data set. And in order to do so, we will need the sentence piece models again. So it's also very important for you to save these models as well. So you will have the 3 files per language pair and the 2 sentence piece models. You can either download them locally, or preferably, and that's what we recommend, is that you connect this notebook to your Google Drive and you can save these data sets straight away into your Google Drive folder. So the way to connect your Google Drive is that you just run the cell to connect to your drive. So here you have to kind of allow access. So you have to say, okay, it's okay to connect to my Google Drive. You then need to select your account, your Drive account, and at the bottom here you need to click on allow. So these are kind of the steps you need to do. And then you can see in the end, if it's connected successfully, it will say Drive mounted. This takes just a few moments to load. And then you can see here it says mounted at, and you know, okay, it's connected successfully. And then there are 2 options of saving this data. Either you can just save it into your general Drive folder, as would be done here. And then by clicking on here, you can check what is in your Drive. Or specifically, you can save them in a folder. I'll go into more detail now. So now we have connected this notebook to a Drive, which means to the general Drive folder. So it's always automatically called My Drive. You can see that here, whenever you're in Google Drive, it's always called My Drive. So if I would save the data sets, I would save them straight away into here. But maybe as me, you have a lot of information there already, and you want to work with a separate folder to save this data. Then you could skip this step and go here. And let's say we create our own folder called empty data preparation. And you can just copy this here so that there will be no spelling mistakes. And then we would go into Drive. We would create a new folder. And this one, we can just paste the information here. And we have created a new folder called empty data preparation. And as you can see, this folder is still empty because obviously we haven't done anything yet. But if we go back here, we can see that now I'm referring to the empty data preparation folder and we can copy all the files straight away into that folder. So here we're copying the sentence piece models, the source and the target, and the 6 sub-datasets. So then you can just run the cell, and it will automatically copy all the files that we've been working with in this notebook. And you can do so and you can check by running the cell below, and you can see, okay, the folder was empty before, but now we should have all these files in that folder. And you can obviously also check with your own eyes in the folder. And you can see it always takes a moment to load, so don't worry. But you can also just reload the page. And then you can see here, successfully, all the datasets, all the files have been saved here. Our source and target sentence piece models, and then the 6 subworded sub-datasets. So this is the information we will need later on to work with in our NMT training notebook, for which we will have a separate tutorial video. And in that notebook, in that video, we will refer to the files that we have saved here. So if you keep this the way you have it now, without renaming anything, we can refer to the files, and you can train your actual individual NMT model. So congratulations, you have saved the data sets that you have cleaned, filtered, subworded, and then split for NMT training purposes.